So let's start. So last time we highlighted the Mason gain formula and the signal flow graph, correct? And simply we stated that the signal flow graph is another representation of linear
دكتور
time.
انت بتكتب شيء؟ لا مش طالع.
Are you sure?
يس.
Okay. Let's see. I will reshare it again. I will share all of my desktop. Okay. And now.
هسه طلع.
Okay. So last time we stated that the signal flow graph is another representation of linear time invariant system. In which we only have nodes and branches, in which we only have nodes and branches. So simply, these nodes are signal. So each signal is represented by a node. Here, okay. Each signal is represented by a node, and simply we need branches in order to connect the node. So this is a unidirectional branch, or let's say path, unidirectional path connecting the nodes. Good. Yeah. So if we have the following block diagram, which is the famous feedback connection, let's say. Where let's assume this is the input R of S, this is the output Y of S, and here we have G of S, and here we have H of S, and let's assume that this is a negative feedback. Okay. Now this is what we call it. We call it the block diagram representation. This we call it the block diagram representation. Yes. And simply, I think last time we highlighted, if we have a linear system, then it's sufficient to have summation and multiplication to represent any algebraic equation, correct? Yes. If you have whatever algebraic equation, you can represent it using only, let's say, two mathematical operation, which is the summation and multiplication. And by summation, I'm including the subtraction, and by multiplication, I include, let's say, the division. Now, if I need to go from the block diagram to the signal flow graph, then for each signal, I will represent by a node. Now let's see. This is the input, correct? A signal. Now here I'm having comparator, which is actually summing, huh? And here I'm having a signal, and this signal is actually what? E of S. the error. Yeah. Yes. And here what I'm having, the output, which is what? Which is the result of the multiplication of the transfer function by the error, correct? Yes. Hello?
Yes. Yes.
Okay. Okay, please give me echo, huh? Okay. In order to continue speaking, I need from time to time to cheer me up, huh? Otherwise I will sleep, by the way. Okay, let's try. So simply how many signals here I'm having? Roughly, or the minimum signals, I'm having 1, 2, 3. Someone would say, no, you have here another signal, which is actually what? Which is actually y multiplied by the x. But simply, I don't care about this one. Why? Because in the end of the day, I'm having the main signals that will represent the graph are 3, which is the input, the error, and the output. So for that, I will use 3 nodes. So the first node for the input, the second node for the error, and the last node is for the output. And then I will connect between the nodes using branches, So for the branches, I will use this color here. So from here to here, from the input, which is the R, to the node of the summing point, which represent now the E, I'm having a unity gain, yes or no? Here, can you see? Here, can you see any gain?
1.
1. So simply, if here I let's say this one, and let's assume that I change this one to be here 3. So what I should put here?
3.
Yeah, 3. Do you see? So it's very simple, huh? So sometime, if I'm having 1, I will never write 1. But if I have a number other than 1, I will write. Yeah. So this is a 3 because here I'm having what? A 3. Yes. Now let's return to the usual one. This one. Huh? Now the connection between the signal, E and Y, is a branch, and this branch is unidirectional, and it has a gain over that branch, and this gain is actually what? The transfer function, correct? Yeah. Yes. This gain here is what? Is the transfer function, yes? Yeah. So here I will write G of S, or for short I will write G. Okay, this one is simple, so here I will write G of S. Okay, G of S. Then I'm having a loop, a feedback, let's say, from Y to the E, correct? From Y to the E. So this one here is the feedback, and this one is what? Has a gain, and this gain is H, but don't forget the minus, because in the signal flow graph, there is no summation point. Yeah, there's no blocks. It's only node connected by what? By a series of branches, correct? Yes. Yeah.
Yes.
Good. So someone will say, in order to make it more clear, I can extend this node. By a branch, and this branch will has a gain equal to 1, and now this one I will call it Y. Now this node and this node are identical, correct? This node and this node are the same. Why? Because if I call this one whatever, if I call one this X, can I write the relation between Y and X? Huh?
Y tsawi X.
Yes, so they are the same node, correct? Sorry. Yes. Yeah. So simply now, if I need to write E, for example, E now, who can write it? You will say that E is a node, where the input to the node is R, and the input to the node is y minus h, correct? So this will be r minus h multiplied by the y, correct? Yeah. So last time we stated that if we need to find the closed loop transfer function, which means that I need to represent this system, which is the same as this system, by a single block or single branch, only has input and output. And here the input is the R and the output is the Y. And here I can call it T of S because here I'm having G in order to distinguish between them. And this one we call it what? We call it either the equivalent transfer function, or in general I will call it closed loop a transfer function. Good. So simply we can use Mason-Gain formula. So according to Mason-Gain formula, T will equal the summation from I equal to 1 up to N Pi delta I over delta, correct? Yeah.
Yes.
Good. So simply if I need to find it, I need to find the paths, the loop, and the determinant, correct? And last time we defined all of that. So simply here, the first thing I will start is the loop. So the loops. And for that, simply, I can mark the nodes by 1, 2, and if you it, this will be what? 4. So give to each node a label, huh? Give to each node a label. Now, stand on node number 1. Can you go from 1 and return to the 1 in the same direction of the arrow without enclosing any other node more than once?
No.
Can you?
No.
No, you can't see, yeah? So simply you will go where? To the node number 2. Now, can you start at node number 2 and return back to node number 2 in the same direction of the arrow? Can you?
Yes.
Yes.
Do you see it? Yeah? Do you see the loop? Yes? The laser point?
Yes.
Yes. Yes.
Okay, good. So now I have a loop and I will call it L1 and I will call it this one L1. And L1 is the gain of the loop, and last time we defined the gain of the loop as the multiplication of all transfer function forming the loops, correct? Yes. So simply who can give me now the loop gain here is equal to what?
Minus GPH.
Minus GH. Yeah, thank you. Yes, and simply this is connecting which point? Connecting point 2 and 3, correct? This loop passed through point 2 and 3, yeah?
Yes.
Now, stand another time in 2. Ask yourself, can I go another path? Can I have another loop? Is there another way that I can go from 2 and return back to 2? I don't think so. No. Why? Because only it has one branch out from it. So simply it has only one way, correct? Yes?
Yes.
Yes.
Okay. So simply, if already we decide the loops and single, there is no meaning for touching and touching. So automatically, I can write the determinant delta, which will equal here 1 minus the summation of all loops, and I don't have any combination. Why? Because I'm having only a single loop. Yeah? Correct? So delta here equal to what? 1 minus L1. If I substitute the variable, it will equal to what? 1 plus GH. Correct? Yeah?
Yes.
Now, do you know that this one is the characteristic equation? Why? Because the transfer function in the end of the day will equal to what? Numerator over denominator, correct? N of s over d of s. And d of s is what? It is the determinant, correct? Yes? So similarly, this actually is what? Delta equal to 0 is the characteristic equation. Okay. Now, in order to find the transfer function, I need to find what? The path. So I need to find the path from the input to the output. So here, for the path from R to the Y. Now stand on the R. Look toward the Y. How many ways I can go from R to Y?
1.
I'm turning off the AC. Huh? How many ways?
1.
Which is?
From node 1, 2, 3, 4.
Yeah, can you give me the gain for that?
G of S.
Yeah, thank you. So simply here, I would say I'm having only one P1, which actually this path. Do you see it? Can you see my laser point? Yes?
Yes.
Yes.
I will try to enter to my phone to see what you can see. Huh? I'm curious what you can see, by the way. Okay, so let's join here. Join now. Okay, I can see now my screen in front of me. Okay. All right. Okay. So now P1. Okay, let's make it silent. This one here. Okay. Just a minute to see. Oh, okay. Everything seems good. Okay, let's turn it off. Okay. So now P1 is equal to what? Huh? P1 equal to G, huh? I don't need to say 1 multiplied by G multiplied by 1, huh? It's 1 actually multiplied by G multiplied by 1, and this is what is the G. Now, and this actually is connecting 1, 2, 3, and 4. If I need to calculate the cofactor, delta 1. Delta 1 equal to what? Delta 1 equal to delta such that any loop touch the path equal to what? To 0. So the loop touch the path go to where? To 0. So where I will return back to this definition, huh? Here, not before substitution, not after substitution, before substitution. And I'm having only L1 and I'm having only path 1. So simply, is there any common node in between?
Yes.
So this means that L or the path P1 touch the loop L1, yes or no?
Yes.
So instead of L1, what I will put?
0.
0. So simply this means that delta 1 is equal to 1. Yeah. So if this is the case, now I can write the transfer function, the closed loop transfer function as P1 delta 1 over delta if I substitute the variable, B1 will equal to what? G over what? 1 plus GH. Yes?
Yes.
Correct? Correct? Which will equal to what? G is what? The forward path gain, correct? Yes or no? G
Yes.
over 1 minus the loop gain, correct? Yes or no?
صحيح دكتور.
Yeah. Now the loop gain was equal to what? Minus
minus GH.
GH. Yeah. And the forward path gain was equal to what?
G.
G. So if I substitute, I will get this one, correct? Yes?
مظبوط.
Good. Now, let's start with another example about Mason gain. So here I will start with another example, let's say. And for that, I will choose the following example. Is this program better than the whiteboard, by the way? I know the whiteboard is fancy, which means that it's more elegant. But simply, I think we have a problem in the cursor, maybe.
دكتور قبل الكسر ما كان يبين.
Yeah, and even if I go back to the, let's say, recorded video, I cannot see the cursor. And this will make, let's say, a confusion for some of you. But simply I search, this is an open source, which means that it's free. It's created by engineer like you who love science, and it's free of charge. Of course, it's not fancy like the MS Teams, but simply I think it will be good. I hope so. So let's assume this is the input, this is the output, and here I will say this is G1, this is G2, and this is H. And let's assume here a negative feedback. Yes? Yep. So let's assume that the first thing I need to find, or I need to plot the signal flow graph. So here, let's assume that what I'm asking you is to plot the signal flow graph and find the closed loop transfer function. Or sometime only I will tell you find y of s, for example. And to find y of s, I need to find what? The closed loop transfer function, correct? Because in the end of the day, y must equal certain transfer function multiplied by what? By the input, correct? Yes? So if I need to find y, this is for sure, I need to find what? The closed loop transfer function. Let's fix this one. Okay, so y of s. Good. So someone will say, by the way, I can do it without plotting the signal flow graph, and I think later on you can do that without plotting the signal flow graph. But in general, in order not to make any mistake, I recommend you to plot the signal flow graph at least in the first stage. After practicing, you can find, let's say, the loops, the paths without plotting the signal flow graph. So let's start plotting the signal flow graph. Okay. So how many signals I'm having here? How many signals I'm having here? Now let's see. This is input, a signal. Yeah. This is what? Error signal. A signal, correct? Yes. This is what? The output. So here I'm having 3 signals, yes or no? Someone will say, okay, I'm having here a pick off point, yeah? but simply the signal here and the signal here are the same. Yes or no? Yes?
Yes.
It's the
Yes.
same. The signal is the same. If this one is X, then this one is X. Yes? So simply here I'm having only a 3, let's say, representative signal. Huh? So this one I can call it the error E. Of course, I can call it X, I can call it Z, I can call it Y. At the end of the day, if you know the meaning, it will be no problem. Yes? So for that, I will use 1, 2, and 3. Good. And let's connecting. This is the R, this is the E, and this is the Y. Yeah. And the connection between the input and the node, this node, is actually again 1. So I will not write 1 here. It's obvious. Then between E and Y, I'm having 2 branches. The first one is the G1, and I'm having another one which has again, which is what? Which has again, which is a G2. And simply, if you need to make it more elegant, let's pick this one out. Okay, or let's use using the same color. Let's pick this one out, and this is actually is the Y. Yes, yes. Now I'm not changing the signals, by the way. Still, I'm having what? I'm having 3 signals. Yes, but simply this is more elegant to be the R and the Y. Yes, and here I'm having what? A branch, and this branch is 1. Now between Y and E, I'm having a feedback, which is this one here. Yeah, and the gain of that is what?
Minus H.
Yeah, minus H. Thank you. Minus H. Yes. So now the first thing, let's label the node. So let's assume this is 1, this is 2, this is 3, and this is 4. Now the first thing I will start is the loops. Don't start with the path. Start with the loops. Why? Because the loops will never change if I reconfigure the input and the output. And now I will give you example for this one. So the first thing, this is my recommendation, start in finding the loops. So the loops. Now, of course, R will never have a loop because there is no branch entering to the R. So I will go to the number 2 node, to the node number 2. Now, node number 2, can I have a loop here? Can I do loop? Can I go from 2 and return back to 2 in the same direction of the arrow without including any other nodes more than once?
Yes.
دكتور.
The first one.
Yes.
First one.
G1 بعدين نرجع الماينس اتش اي
minus H. Do you see it? Minus H. So simply this will be the L1, I will call it L1, which is equal minus GH. And here I will highlight it with the white color for your use. Yeah. Okay. The second loop.
دكتور نكتب G1 ولا لا؟
دكتور ما في.
Yeah, G1, yeah. I'm too old, yeah. So sometimes I'm saying G1, but I'm forgetting to write. Anyway, thank you. Yeah, of course, it's G1. There's no G here, huh? Okay. The second loop, what is it?
دكتور ما في second loop.
Are you sure?
Yes.
What about if you look to the circle? Do you see the circle? Is there any circle?
Oh yeah.
Yeah, there's a circle. Yeah, there's a circle. Now here, maybe you will have excuse in the exam. You will never have excuse. Yeah. So you should look not once or twice, 3 times. Ask yourself, stand on the node number 2. Ask yourself, can I go from 2 and return back to 2? And the answer is yes, I can go. I can fly. Do you see it? see it? Yes? Yeah?
Yes.
Yep. So this one, I will write it in yellow. So this will be L2. And who can give me the gain?
minus G2H.
Yes, thank you. Minus G2H. Good? Good. Now, is there any other way? Of course not. There's no way. Why? Because simply I'm having here two branches out. So simply this means that the maximum thing I can have is 2, correct? Yeah. And I'm having here single. So if I'm going to 3, this will end everything. Or let's stand on node number 3 another time. Ask yourself, can I have a node? Can I have a loop? Can I have loop at 3?
No.
Someone will say, what about minus H? Huh? What about minus H? G1, this one. This one is already here. Yeah. Yes. So simply this means that the loops must be independent, huh? Which means that this one actually is the same, huh? You should not. So if you have, in the end of the day, if you have loops which are identical, this will give you clue that you are duplicating the loops, huh? But you should check the signal flow graph to be sure for that. So now here, in terms of the bracket, I will add L1 was connecting to node 2 and 3, and L2 is also connecting 2 and 3. Is there any common node in between? Is there any common node between L1 and L2?
Yes.
minus H أو الاثنين يعني.
Two nodes. Two nodes. Huh? So they are touching, huh? They are what? Touching. They are touching loops, correct? This is, let's say, a basic check to guarantee that the loop are touching, or let's say to check if the loop are touching or not touching. If there's any common number here in between, this means that those loops share a common node, and this means that the loops are touching, correct? If the loop is touching, simply this means that delta will end up to be 1 minus the summation of all the loops. I don't have another terms. Why? Because the other terms is for what? For the non-touching loops. All possible combination for 2 non-touching loops. All possible combination of what? Of 3 non-touching loops. And simply here I'm having 2, and those 2 are touching. So simply I will end here. So let's substitute. If I substitute, delta will equal to what? 1 plus G1H plus G2H, correct? Yes?
Yes.
Yeah, good. Now, let's find the paths. And for the paths, I need to specify the inputs and the output. And here, because this example is single input, single output, maybe I will not write, but for you, I will write from R to Y. To tell you that I need to go from where? I need to go from R toward Y in the direction of the arrow without enclosing any node more than once. Can I go from node 1 to node 4 in the direction of the arrow? Can I?
Yes.
Yes, the first one. So P1 equal to what? Where I can go. So I'm here. So I will go to where? To node 2, then 3, then 4. Do you see it? The line that's
Yes.
cutting the signal flow graph. Yeah. So this is the first path. So simply here, can you give me the gain for that?
G1.
G1, and the nodes are 1, 2, 3, and 4. Yeah. Yes. Now, if I calculate P1, let's calculate automatically delta 1. Delta 1 equal to what? Delta such that any loop touch the path equal to 0. Now, is there any common point here between the loops and the path?
Yes.
Yes, so simply this will equal to 1. Why? Because L1 will equal to 0 and L2 will equal to 0. Yeah, this read as what? 1 minus L1 plus L2. So you are evaluating here the cofactor. Yes. Now, P, ask yourself again, can I go from R to the Y another way?
Yes.
Is there?
Yes.
Which where?
من عند الجين G2.
Yeah, I will fly, huh? I will jump. Yeah, I will jump. So this will be what? G2, which actually connecting 1, 2, 3, and 4. That delta 1 is equal to 1. Delta 2, sorry. Delta 2 is equal to 1. Yes or no? Yes. Why? Because this path touch all the loops. So simply for that, I can write for you, if the path touch all the loops, then simply delta of the path will equal to what? To 1, correct? You don't need to think about. Yeah, if the path touch all the loops, then the cofactor for that path is equal to what? Is equal to 1. Yes?
Yes.
Yeah, good. So now, can you give me the closed loop transfer function equal to what now? T. T now is equal the summation from I equal to 1 up to n pi delta I over delta. And this will read as P1 delta 1 plus P2 delta 2 over delta. Yes or no? Yeah? No. Now, simply if only my concern to find the transfer function, you can stop here. You don't need to substitute. Why? Because I know delta 1, I know P1, and I know delta. Yeah? But if I need to calculate the response later on, so simply you need to evaluate. Huh? You need to find the transfer function in, let's say, in order to find the response in time domain. Yes? Yeah? Okay. Now, what about for this example? What about for this example, if I'm telling you that, I have space. Yeah, thank you. I'm having space. Okay. What about for this example? If I'm telling you that I need you to find the transfer function where the input E over R equal to what? Yeah. And and what about if I need you to find Y over E is equal to what? Yeah. Now, the first transfer function, this one, do you see it?
Yes.
The input is what?
R.
And the output is what?
R.
The input is R and the output is
It's E.
E. So automatically this means that I need to pick off the E. So automatically this means that I need to pick off the E. In order to find it, I need to pick it off with gain equal to what? To 1. It's like what? If I need to measure without cutting divide, huh? I cannot. Correct? Yes. So simply this means that this node and this node are the same, yes? Yes. Yes, they are the same with gain equal to 1. Okay. So now let's see. Now here the input is the same, but the output is changed. But the loops will never change. Now the loop is changing. If I change the output, the loop is changed.
لا
No.
No. So touching, non-touching are changing? No. So simply this means that I have the determinant. Automatically I'm having a determinant. The only thing will change is the paths. Why? Because I change the output. Huh? So now for this one here, I need to find the path where the input is R and the output is E, correct? Now ask yourself how many ways I can go from R to E.
واحدة.
Only one. So this will be P1 and this will equal to what?
واحد.
1. Thank you. Now, and this connecting node 1 and 2. Yes?
صحيح.
1 and 2, and if you need to put this one, whatever, I don't care, but this one will never change anything. So only I will keep those, the main nodes. Now, 1 and 2 share number here in the loops.
الاثنين.
So simply automatically mean that the delta 1 is equal to what? To 1. Why? Because the loop touch all, because the path touch all the loops. Yes?
صحيح دكتور.
Good. So simply now, can you give me the transfer function equal to what?
واحد على واحد زائد G1H زائد G2H.
This means then E over R will equal 1 over 1 plus G1H G2H plus 0. Yes? Yeah?
مظبوط دكتور.
Okay. Now, what about this one? Who can evaluate this one for me?
دكتور هاي حتكون G1 زائد G2 على واحد زائد G1H زائد G2H.
It will equal to what?
G1 زائد G2
G1 plus G2
على واحد زائد G1H زائد G2H.
1 plus G1H plus G2H. Who agree with mean mine?
محمد الحسن.
Muhammad Hassan. Who agree with Muhammad Hassan? Or before that, someone should ask Muhammad Hassan how you find this one. Yeah.
دكتور في عندنا البي 1 اللي هي G1 حتكون.
Okay,
And
B1. Do you see B1? Do you see B1? So this means that you are taking highway in the opposite direction. Yeah. Can you go in this direction, man?
ما مظبوط.
No. Can you? Do you see the arrow? Do you see it?
طيب.
Can I go in the opposite direction? No, I cannot.
No.
Otherwise, I will take a ticket and maybe I will go to the jail. Huh? No, I cannot. Unfortunately, I cannot. So simply this means that there's no direct path. Yes. Is there a direct path between E and Y? Don't tell me this one. This is not E. Huh? If I need E, I need to pick it off. Yes. If I need any signal here, if I need it, I need to pick it off. Yeah. Here Y, I'm picking off Y. Here E, I'm picking off E. So simply there is no direct path between E and Y. So in this case, Mason will fail. Yes. Yes or no?
صحيح دكتور.
Yeah, but there's a work around. Now let's see. Y over E is equal to what? Do we have Y over R? We have it. This one we have it. Yes. Do you know Y over R is what? This one. Huh? The transfer function. Already we found. Yeah. Yes. Yeah.
صحيح زي اللي قبل شوي قلته. هو G1
Yeah.
زائد G2.
Multiply by what?
R على E.
Yeah, R over E. Yes. Now, according to the Pacman theory, do you know Pacman theory? Huh? You know Bachman? According to the Bachman theory, R will eat R. And we will end up to what? To the Y over E, which is what we need, huh? Yes? You don't know Bachman theory, huh? You know Bachman?
نعرف اللعبة.
Yeah, this is the same. It's the game. It's the Bachman theory. I'm eating the terms. Don't remember that. It's out topic, this one. But maybe in the future you can find something you call it Bachman theory. Whatever. Huh? So now I need to find Y over E, which will equal Y over R was what? Do you remember Y and R was what? Oh, really? This one, huh? We found it. I need to evaluate. Huh? Let's evaluate. So do you remember it was P1, 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 G1, G2? It was
G1 زائد G2.
Yeah, G1 plus G2 over the 1 plus G1H plus G2H multiplied by the inverse of this one, correct? Yeah?
مظبوط.
Which is multiplied by
1 زائد G1H
1
زائد
plus
G2H.
G1H G2H over 1, huh? Yes? And according to Bachman theory, what I will have?
G1 زائد G2.
Yes. So Y over E will equal to what? G1 plus G2. Yeah. Good. So this is a workaround in order to find the transfer function in case I don't have a direct path between the input and the output, or in case of the missing gain formula is failing. Yes? Understood? Good?
Yes.
Okay. Now, do you know Mason gain formula is actually Kramer rule? Do you know when I need to solve a set of the algebraical equation? Huh? Let's say x equal a or whatever z. If I need to find the solution here, simply in linear algebra, you have two options. Huh? Yes. Yes. How you can solve this one in linear algebra? One is to eliminate, huh? In order to make this one what? Diagonal. Then you find what? The last solution, then you substitute. Yes?
Yes.
The second one is called the Kramer rule, which means that you will find the determinant. Then you are substituting the output instead of the variable you are interested in. Then you are calculating the new determinant. Then you are dividing, correct? Do you remember that? Yeah, this actually is what? This actually is the Kramer rule. So do you see Mason? Mason was clever actually. Huh? Mason was genius. Why? Because from very simple, let's say, algebraical fact, he built something useful for control engineer. And this actually the engineering. Engineering is not to create the wheel. Engineering is to use the wheel. Yeah. Of course, in the end of the day, after using, you can create it. Good. Okay. So let's start with another example. And for that, I will use this example. Before that, do you have any problem with how to define the loops? How to define the path? Huh? Do you have a problem with that? And for that, let's ask. Let's ask. Okay, for that, Yusuf.
نعم
Yusuf,
دكتور معك.
do you have any problem with that?
No, everything
No
obvious.
problem at all. Good. No falafel for you next time. Muhammad Mahmoud. This one. Do you have problem?
لا.
Oh, good. So in the exam, you will never have problem, inshallah.
Inshallah.
Inshallah. Anas Faisal. Do you have problem, Anas?
No, Doctor.
Okay, good. So now I'm having 20 attendance. Okay, that's good. Let's see. Okay. So with another example. So this is another page. Yep. So for that, I will choose the following example. This is another example. And let's plot this one here. And let's assume we have the following configuration, which can represent anything you can. It can robotic system. It can represent, let's say, your car, whatever. Let's assume that we have the following configuration. And for that, let's assume here I'm having the first feedback or the first connection here, negative. This is H2. This is the G1. This is the G2. And this will be the G3. And this will be the G4. And let's assume here I'm having a direct connection from here toward this node. Yay! Go. Good enough. Or let's replot it again. Yay. Okay, I think this is better. And let's assume this is a G4. And let's assume that I'm having another feedback.
دكتور اللي فوق
دكتور
طبق
سميت
G5
G4
لأنه في
مرتين.
G4.
Okay, G4. So you can put dash on that. Okay, I will change it. But I mean, you can put the dash. Huh? So it will be G4 dash. Whatever. Okay, and this is what? G, 1, 2, 3, 4. After 4 is coming what? 1, 2, 3, 4. After 4 is what? Huh?
5.
Yeah, thank you, 5. And this is the beauty of the numbering, by the way. They are in sequence. Okay. Yeah, G. I'm forgetting this. Okay. Okay, thank you. Okay, now. I need to specify the input. And I need to specify the output, correct? Yes? Let's make it more interesting. Yes? I will inject another input here. And this input, I will call it D of S. Yeah? Another, make it more challenge. I will inject another input here. And I will call this one what? Choose. Maha, choose a label here. Huh? What I can call this one? Can I call it W? Huh? W of S? Yes? Can I? Can I? Who's lifting? Okay, now let's see. All right. Return back. No. Okay. Yes. So I can choose whatever label. So how many inputs here I'm having?
3.
3. Yeah, this is answering or questioning?
لا 3.
Answering. 3. So make self-confidence. 3. So 3. So how one? Do you need to make it more interesting? Huh? Now, how many outputs I'm having? Two. Yes, two. And simply what I need to find the transfer function. I need to find, let's say that, so I need to find y over r equal to what? I need to find y over d equal to what? I need to find w or y over w equal to what? I need to find, let's say, z over w equal to what? Yeah. I need to find d or z over d equal to what? Correct? Which means that I need to find all the mix, all functions that I can find. Yes. Yeah. Using what? Mason gain formula. So the first thing, I will plot the signal flow graph. How many signals here I'm having? How many signals I'm having?
خمسة.
The first one, the second one, the third one, the fourth one, the fifth one, the sixth one, and here I'm having for each one is a signal, correct? Yes? Yeah? Correct?
Yes.
Yeah. So let's start plotting. So the first one here, and this is the second one, third one. And let's connect the first one here. This is the R. This you can call it whatever you want. So let's number it. So this will be 1. This will be the 2. Now this will be the 3. This will be the 4. This will be the 5, node number 5. This will be node number 6. Now between 2 and 3, the first branch here I'm having is G1, correct? Yeah. After that, I'm having what? G2. After that, what I'm having? G3. After that, what I'm having? G4. And simply here you can extend this line in order to only to write the wire. Yes. Yeah. Now let's see. Between two, so this is the 1, the 2, the 3, the 4, the 5, the 6. Between 2 and 5, I'm having connection, correct? Yes. Between 2 and 5, I'm having connection, and the connection has a gain, and this gain is equal to what?
G5.
G5, yeah, thank you. Yeah. Now, what else? At 3, I'm having inputs, and this input is D of S, correct? Yeah. And between 3 and 4, I'm having a feedback, and the gain is equal to what? Minus H2. Minus H2, yeah? Yes? Now, from 4, what I'm having? Output, and this output I call it what? Z of S with a unity gain. Yes? Yeah. Now, after G4, from 6, I return back to where? To 2, yes? So from 6, I'm returning back to where? To the 2, yes? Yeah, so let's replot it again. From 6, I will return back to 2 with gain equal to what? There's no gain here. This will be H1. I forget this one, H1. So the gain here is equal to what?
minus H1.
H1.
Minus H1. Because you should respect the sign. Yeah, thank you. So this will be minus H1. And I think here I'm having input. At node 5, I have another input. And this input is called what? W of S. Yes? So here I'm having W of S, and this one is what is input. Now, the first point I need you to remember and keep in mind. Do you see any branch without arrow? In the block diagram?
No.
Or in the signal flow graph, I will never plot a branch without arrow. Why? Because the arrow indicates the direction of the flow. And if the signal flow graph has no arrow, this means that I cannot judge where is the direction of the flow. Yes? Yeah? Yes?
Yes.
Good. So keep this in mind. Okay. So the first thing, this is actually an example for what? For multi-inputs, multi-outputs, correct? I'm having 1, 2, 3 inputs, and I'm having 2 outputs, correct? Yeah. So simply here I will write, this is example for 3 inputs and 2 outputs, which means that this multi-input, multi-output linear system. Of course, if the system is represented by a transfer function, for sure this system is called linear time invariant system. Linear time invariant system. Good? Yeah? Yes?
Good.
Okay, good. So now let's see. Here, how many lists I'm having? 19. So for you, do you see the 19 here? Yeah. I will give you a quiz, only for you to find 2 transfer functions. The first one and zy, and this one. Yeah. So this is what? A quiz for you. Yeah. And the time will end at the end of the lecture. At the end of the lecture. So you have from now to where? Until 10. And only I will accept answer from where? From this list. Yes? Good? Understood? Hello?
Yes.
Good. So take your time.
دكتور التسليم على e-learning.
Yes, and now I will open it.
Okay.
And only I will accept answer from those who attend. Understood? So don't post anything to your friend. I will never accept anything. So simply only I having the list now. Good. And here we go. يلا يعطيك العافية. And by the way, it's open book, open note. And if you need anything, you can ask me. I will stay online.
في مجال بس السؤال نفس يعني.
This is my screen. So I will keep this screen. I will stay online. Okay. And let me post it on the e-learning. Yes. Go, 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 go. You need it, by the way. You can ask. If you cannot understand anything, you can ask. So simply, this can be a reward for you. Not e-learning. And before that, let me only just a minute, huh? Just print screen.
السؤال الثانية
Huh? Yeah, just a minute. In order to keep the thing clear, I will turn off my video. And just a minute, huh? The first set here, and the second set are here. Yes, محمد تفضل. بدك السؤال مرة ثانية؟ محمد. في أي سؤال؟
دكتور السؤال شو هو
find two transfer function. This is the first one, and this one. Can you see this one? Can you see it? Okay. I think here there's a marker, and this is also I later on I discovered it. Huh? So let's use something blue. This one and this one. Can you see it? Yeah?
دكتور واضح.
Okay, so let's highlight the circle. Circle it. And circle it. Good. So I'm posting now to the e-learning. And it will end at 10. Huh? And okay, we are in 27. So I will add here, add activity and assignment. So this will be quiz number 2. And here I will write find find, let's say, okay, I can be more professional. Yeah, okay. Right, so let's use the index. Okay, so y over r and z over w. Okay. Okay, and for the following system. Okay, save equation and okay, let me shoot this one. Bismillah. Okay. It starts 27 at 9:45 and end at Okay, October 27 at 10. At 10, okay. Okay, cut off date. Okay, save and display. So let's stop recording. I think it's enough to record this one. So stop recording. The meeting is being recorded.